I bought an inexpensive simple board to build a power bank. Thanks to YouTube, I pays like this a whopping 15 cents a day on average. And now we'll live like this. You can buy whatever your heart desires and not deny yourself anything. And so finally I saved up $1 and bought this board. I already printed the board to speed up the process. Here it is from one side and the other. The main microcircuit is a TP5407. The second is this one, 1067, according to this inscription. That's the name of this microcircuit. They soldered this button here, as I understand it, to turn the power bank on and off. Two USB outputs. There's a Type-C, a micro for charging. On the other side, there is a pad like this for cooling. This micro circuit, which will overheat during operation. We can glue a small heatsink here. The contacts for connecting to the battery can be soldered on this side, or on this one. So it's also a plus minus designation. And here's a plus minus. So everything will show up easily. To test the board, I'll first connect the 4V power supply, minus to minus, plus to plus. And let's see how the board turns on and how the LED indicator light up. Look, they're all lit up. This is the minimum and maximum battery charge. Now I'll check the output voltage. I've connected a voltage tester, and then what the USB output shows that current is 5V and the current should be 0. Now it will switch, yes, to 0. Now I'll check this connector. Look at the second one. Well, the second one is also 5V, and the current will be 0. It switches somewhere in 2 or 3 seconds. Here's this voltage tester. Yes, here's the current 0. Just out of curiosity, I'll check the voltage of the input. Well, approximately 4.2 volts. I'll solder this holder to the board contacts. And I'll test two batteries. One is almost charged, 4V, and the second is about 3V. What's here? Here we have 34, and this one has 115. That is, this one is practically fully charged. This one needs to be charged, and we'll see how the board works. I solder the minus to the minus, the plus to the plus. When connected, we see that one LED lights up here. So this button does something. I press it, it does nothing. Let's change the battery, for example, with this one. I put it on a 4V battery. All the LEDs light up. That is an indication that the battery is charged. This one, that it was discharged. There it is, on 4. This one is on 4. Here it is. 3. Yes, here are 4. Here are 3. After a few seconds, the LED stopped lighting. So I understand a button to turn on the LEDs. Yes, I pressed it. The indicator there. And then it automatically goes away. Well, that is the button simply turns on the indicator. Well, and possibly the output voltage. Now I'll check with a tester. I connect the tester to the output. There's 5V. It worked automatically. And even when the LED is off, there's 1. And the second one. Second one is there too. I press the button and it only turns on the LEDs. This button. The output automatically produces voltage and current, even when the LEDs are off. Now I'll connect a power supply, for example, an outdated type with a micro USB port, and see how the battery charges. I plugged it in and it started charging. Well, it's practically charging here. That's when all the LEDs light up. Now I set it to 3.4 volt. I connect the charger. Well, the charging starts. That is, at first one LED will light up like this, blinking, then the second, the third, and so on until the last one. So that's the board. It's cheap, but it's good enough for a simple power bank. You can make different power banks. The output is 4.2 volt on the board. You can see the microassembly is warm, but it's bearable.